Hi guys, this is Rahul, DevOps engineer. In today's video, I will show you how to create a pod in Kubernetes cluster. Okay, and basically we have two tasks. Task one, we have to create one pod in the Kubernetes cluster, and in second task, we'll create multiple, at least 4 pods with the same configuration using ReplicaSet. Okay, so task one. One pod we have to create with below specifications. So image, we'll create a pod or a container which is running uh, centos image, and the CPU that can be allocated, that pod have is 1 CPU and 1 GB memory, and max it can go up to 2 CPU and 2 GB memory as load will increase on that pod or the container. Okay, so here we can use pod and container uh, vice versa. I mean, there is no difference because we are running one pod with one container. Okay, okay, so on the right side you see the diagram. So this is my Kubernetes cluster. Okay, and in this Kubernetes cluster, one is my master node. Master node specification is 2 GB 2 CPU and 16 GB RAM. And here I have my worker node. It has 4 CPU and 32 GB RAM. And inside this worker node, we will create a pod which will have one CPU and one RAM, and the OS will be CentOS. Okay, and in task 2 I have this diagram, right? This is my Kubernetes cluster in which I have a master node with 2 CPU and 16 GB RAM, and a worker node, right, which has 4 CPU and 32 GB RAM. Inside this worker node we will create 4 pods, right? 4 pods which are running container having image CentOS, and mini and the CPU 1 CPU and memory 1 GB RAM. Okay, and the maximum it can have 2 CPU, right, and 2 GB RAM, right? Okay, so let's go to our lab and we will see how we will achieve these two tasks. Okay, so here is my master node, right? Okay, so our first task is to create a pod with 1 CPU and 1 GB RAM. Okay, so yeah. Now first we'll see, in my previous video I demonstrated how to create 2 node cluster. I will start from there only. So let me see what is the state of my cluster at this moment. So to know the state of your cluster or nodes, you have to run the command kubectl get nodes. So 2 nodes, one is master and one is worker, and both having a status ready. Okay, so let me see if I have any pod running or not. So to check whether you have any pod running in your on your cluster or not, you can use this command kubectl get pods. So no resources found in default namespace. This means no pod is running at this moment. Okay, now to create your first pod, what you have to do, you have to create a YAML file. Okay, I have already created a YAML file for pod. I can show here. Okay, get this. Okay, so this is my YAML file. We can discuss this YAML file here. So kind is, if we have to specify a object what we wanted to do on this cluster, right? So we want to create a pod. So that is why we have taken kind as a pod. API version, it is standard, we will use v1 here. Metadata, here in the metadata section we define name of the pod, okay, and in specification what will run inside this pod, we have to specify that. Okay, so we want to run a container and the name of the container would be c00. Image, the container will be created with image centos latest, right? Here we have to specify resources. Okay, so request means initially when your pod will create it will be created with the 1 GB memory and CPU 1000 milli. This means one CPU. Okay, one CPU means 1000 milli CPU. Okay, so and limits, uh, up to how much it can go, right? So CPU can go 2 milli, 2000 milli to CPU. As soon as, I mean, as load will increase on your pod or container, it can request 2 CPUs and it can request 2 GB memory from the base node, from the worker node, okay, from the pool itself, right? Okay, so now this is the YAML file for the pod. So now we have to create very first pod. So the command to create pod is kubectl apply -f and the file name. So now as soon as I hit the enter, I got the message pod test pod created. So this is the name of the pod. Okay, so now if I want to see the status of pod, the command is kubectl get pods. Okay, now I'm curious where this pod has created. Okay, to find out that we have to we have to repeat this command with the parameter -o wide. Okay, now uh, the name of the pod is test pod and it is created on worker node, and this is the IP address of my pod and its status is running. Age, when it was created, just 35 seconds ago it was created, and here 1/1 means one pod running with one container. Okay, and the name of the pod is test0 test pod. Okay, so this is how we create pod in the Kubernetes cluster. Okay, now if I want to create one more pod, so we can do one thing. Either we can modify this file itself, okay, and we just have to reapply this file, and then you can have a new pod created. Okay, so now we just have to change the name of the pod, test pod 1, let's say. Okay, then, now no other changes are required. We'll go back and we'll apply this file again. Okay, so now if you apply the same file again, so it says pod/test pod1 created. Okay, now we'll use the same command, repeat the same command to see the status. So as you see, now test pod1 has been created and its node is worker node, and its IP address is 192.168.171.126. Okay, let's say if I want to create one more pod. Okay, so I will again go back and modify this file, and let's say the name of this file this time, the name of the pod this time is test pod 2. Rest of the specifications will remain same. Okay, now we'll apply the file again. Okay, now let me see the status of pods. Now another pod has been created, test pod 3, and the age is 6 seconds ago, right? And now this IP address is 192.168.171.115, and the node where it has been created worker. Okay, so you see, I mean, nothing is being from the workload perspective, from the application hosting perspective, everything goes on the worker node. Nothing comes on the master node. Okay, master node is just to manage these pods on the worker node. Okay, now let's say I want to delete the pod. Okay, so deletion of pod is quite simple. What we have to do, kubectl delete pod and the pod name. Okay, let's say I want to delete this pod. So this command executed and it's giving a message pod test pod to delete it. Okay, so in a while we'll get the prompt back. Okay, so this is how we create our pod and on the worker node. Okay, in fact we don't let our master node to know where we want to create the pod. Wherever on the worker nodes it's the space or it's the required capacity, it can create there. Okay, now my pod has been deleted. So if you want to see the status, now only two pod left. Okay, so now I will delete the remaining pod as well, and then we will see how to create multiple pod, because this time we created pod one by one. Right now I want master node to create multiple pods using a YAML file, right? Okay, so kubectl delete test pod one, what it says. Okay, so we have to specify what is this, what we are going to delete. So we are going to delete pod, we have to inform that this is a pod, right? Okay, okay, it takes few seconds in doing the required cleanup, so that is why we have to wait. Okay, okay, now it has been deleted. Okay, now kubectl, let's get the status again. Kubectl get pods, one more pod left, let's remove this also. Kubectl delete pod and then test pod. Okay, so to create to let master node create multiple pods with same specification, we have to create a replica set object. Okay, so now our command has been completed. Let's get back the status again. No resource found in the default namespace. This means all the pods have been deleted. Now we have we want master node to create multiple pods for us, right? So for this we have to create a YAML file that defines our replica set. Okay, so here I have already created one YAML file, right? So we can discuss this here and then we'll apply this YAML file. Okay, so here kind is a replica set. Okay, name of the replica set is centosrs. Okay, and replicas, it will create one pod first. Okay, okay, so we can update it as well. Okay, let's me make it four parts. Okay, we want four replicas created. Okay, so here we want 4 pods created with this specification. Okay, image, the name of the container inside the pod is C00, image is this, centos latest, and the resources, right? So each pod will have, or each container will have 1 GB memory and 1 CPU. Okay, so let's apply this uh, YAML configuration and then we will see how it behaves. So kubectl apply -f. Okay, so here replica set centos rs has been created. Okay, so now let's see the status. Kubectl get pods. Okay, so 4 pods are created. Now see, oh, to get more detail, the this is the IP of pod and the node where it has been created. So now 4 pods has been created. Okay, on the worker node. Okay, now if I go back to my diagram again, so this is my master node and we have created 4 pods, one with specification 1 CPU and 1 GB RAM, right? So this we have achieved through replicaset rs, and this was the first one where we created one pod inside the worker node with 1 CPU, 1 GB RAM, and the OS image is CentOS. Okay, so now let me go back to my right. If you want to delete all these pod in one go, what will you do? So for that again we have to delete the replica set. Okay, so before that, the interesting fact is if I want to delete one pod, right, what will happen? So my master node will ensure that as per replica set there should be 4 pods running. So it will keep on the moment I will delete a pod, it will create another pod to maintain the desired state. Okay. kubectl delete, let's perform this, and the pod, and here. So I have just deleted this pod. So now you will see that remaining 3 pods will be there and one new pod will create. Okay, and that time the IP address which will be assigned to the new pod will be different. So every time whenever a pod crashes or deleted, a new pod is created in place of that, but it always get the new IP address. Okay, yeah, so here I have deleted the pod. Now if I run the command back, so you see, so these are my old pods, right, and this is the new pod which has been created, right? So this is how your replica set helps in maintaining your state. So if I get the status of replica set or detail of the replica set, the command is kubectl get rs. So rs for the replica set. So this is name of my replica set and desired and the current, and this is the ready. So current state is how many pods are running in current, desired how much I want it to be run, okay, and ready how many are ready. Okay, so every time this is the responsibility of master node to maintain this status desired, current, and ready. Okay, so whatever number I'm mentioning here, it has to maintain that number, right? So this is how we achieve the uh, pod creation through the master node. Okay, so I will stop here now, and in the next video I will show how to create service IP, node port, and the deployment, right, and the yeah, So we'll see that in the next video. Thank you so much. I will stop it now. I hope you will enjoy this video and learn a lot, and you also practice this on your in your lab. Okay. Thank you so much.